All right, guys, I want to explain how to do question number 4. We didn't quite get to this in class yesterday or the day before, and so I want you to finish this lab, and I want to collect it the next time that you're here. But in order to do that, I want you to have some background on question number 4, and I'm going to do this with you right on my whiteboard here. So a couple of things to take note of. We have a parallax angle of 0.19444 arc seconds. And you're probably saying to yourself, what in the world does that mean? And how am I supposed to figure this out on my own? So that's why I'm here. Okay, so let's do this right here on the whiteboard. First off, let me explain an arc second. So what we're dealing with here is angles, right? So if I were to draw an arc like this, and let's say from here to here represents 1 degree, 1 degree is also equal to what we call 60 minutes, okay? For every degree, there's 60 minutes. So you could break this into little increments of minutes. There'd be 60 of them in there. Every single one of those minutes could be broken down into seconds. And so 60 times 60 will give you 3,600 seconds in 1 degree. Okay, so we could have 3,600 lines in between here that each represent a second. So really, really tiny increments. If we're measuring stars in the universe, we're talking about very, very tiny little differences in the actual angle compared to what we were doing out there in the field. It's totally different when we're talking about real stars. All right, so just to give you that little background to start off with. All right, so I'm going to erase that. And now let's go back to the idea of parallax. So our triangle for parallax had 2 angles. The one that we were dealing with in class that your lab has is called the alpha angle. That's not the one that we're going to deal with for this question. What we're going to deal with is the parallax angle, which is that little tiny one that's up here at the top of the triangle. This is the parallax angle. And if you remember, it says that the parallax angle is 0.19444 arc seconds. So the first thing I'm going to do is I'm going to change this into actual degrees. And to do that, all you really have to do is divide it by 3,600. So 0.19444 divided by 3,600 gives you our very tiny little degree measurement. It is 5.4, I'm just going to write this down, times 10 to the negative 5 degrees. Okay, that's how small that angle is in reality. Now, what we're trying to figure out is how far is it from the sun, here's the sun, to the star, which is over here, and we'll call that x. Okay, that's what we're trying to figure out. What we know is this Earth distance, it's given to us in the problem, 149,598,000 kilometers, okay, or 1 AU, right, astronomical unit. And so what we're going to do is we're going to do a tangent function to figure this out, okay? So we have to set up this problem. We're going to do it like this. Tangent is equal to opposite over adjacent, okay? So the tangent of this number, the tangent of our tiny little angle, 5.4 times 10 to the negative 5 degrees, is equal to this number, this big number, 1 AU, or 149,598, the opposite, 000 kilometers, over the adjacent, which is x. Okay, so we got to solve for x, which basically means we got to swap places with these two things. Okay, so I kind of rewrite this again. X is equal to 149,598,000 kilometers over the tangent of our tiny little number, 5.4 times 10 to the negative 5th degrees. Okay? All right, so now we have it all set up, and now we just have to do a little bit of calculation. All right, so I'm going to do this all on the calculator from now on rather than writing everything out. So the first thing I'm going to do, because I already have this number plugged in there, I'm going to take the tangent of that number, so tangent of my answer. Okay, so now I have an even tinier number, all right? And then I'm going to do this big number divided by that, so 149,598,000 divided by my answer. And that's going to give me my final answer, which is the distance to the star. And it's a big number, okay? 1.58, and I'm going to round it 7 times 10 to the 14th power kilometers, okay? And that makes sense because that's a really large number. It's a really big distance away. That's the answer to that question, okay? And that's it.